UAP sightings, strange lights in the sky, reports from pilots. It's all pretty captivating stuff, right?
Absolutely, yeah. It really grabs the imagination, doesn't it?
For decades now, these unexplained phenomena have had us looking up, wondering what's out there. And today, we're going to explore a potential link between these UAP sightings and something you might not expect: plasmoids.
Yeah, we're going to dive deep into these fascinating structures, these plasmoids. They're self-organizing structures of plasma, and they've been observed in thunderstorms and even in the vastness of space.
And what's really interesting is that plasmoids exhibit some pretty wild behaviors.
Oh yeah, they pulsate, they shift shapes, they can even split into smaller plasmoids, almost like they're alive.
It's kind of mind-blowing when you really think about it, and that's just the tip of the iceberg.
We're also going to touch upon quark gluon plasma.
QGP.
Yeah. It's a state of matter that existed in the very first moments of the universe. It's pretty intense stuff, but it ties into this whole discussion in a way that might surprise you.
Well, I'm ready to have my mind blown. Let's get into it. So first things first, I think it's important to make sure everyone's on the same page. When we talk about plasmoids, we're talking about plasma, right?
Yeah.
But what exactly is plasma?
So yeah, plasma is often called the fourth state of matter. You've got your solids, liquids, gases, and then there's plasma. And it's actually the most common state of matter in the universe.
Really? More common than solids, liquids, and gases?
Oh yeah,
Really?
Way more common. Stars are made of plasma, nebulae, lightning.
Wait, lightning, that's plasma.
Absolutely. When you see a bolt of lightning streak across the sky, you're seeing plasma in action.
Wow, I never knew that. Okay, so plasma, it's everywhere.
Pretty much. Now think of plasma as a gas where the atoms have been stripped of some of their electrons. This creates a sort of electrically charged gas that can do some pretty interesting things.
Interesting, how?
Well, for starters, plasma can conduct electricity. It can also be influenced by magnetic fields, which is how those dazzling auroras are created.
Ah, the northern lights. Okay, I'm starting to get the picture. So how do we go from this energized gas, this plasma, to the formation of a plasmoid?
Good question. It's all about self-organization. Under certain conditions, plasma can spontaneously form these distinct structures we call plasmoids. Think of it like a whirlpool forming in a river.
So it's kind of like order emerging from chaos.
Exactly. And what's remarkable is that these plasmoids can be incredibly stable and exhibit complex behaviors, even though they're essentially just organized bundles of charged particles. They really are fascinating.
It's making me think back to those UAP sightings we were talking about earlier. Are you saying there could be a connection between plasmoids and some of those unexplained aerial phenomena?
Well, that's what some researchers are suggesting. Yes. Think about it. Plasmoids forming near thunderstorms could interact with the Earth's magnetic field in ways that create visual and radar anomalies. Those anomalies could easily be mistaken for something more, out of this world.
So a plasmoid could appear on radar as an unknown object moving in ways that seem to defy our understanding of physics.
Potentially, yes. Especially if we're not fully grasping how plasmoids interact with electromagnetic fields. There's still a lot we don't know.
That's pretty wild. So how do we go from speculating about plasmoids and UAPs to actually getting some concrete answers? I know the sources we've been looking at mention drones playing a crucial role in this research.
Absolutely. Imagine a drone equipped with, say, a spectrometer. It could analyze the light emitted by a plasmoid, giving us insights into its composition and temperature. Or equip the drone with a magnetometer to map the plasmoid's magnetic fields.
So essentially, we'd be using drones as mobile laboratories, gathering real-time data on these elusive structures.
Precisely. And that data could help us confirm or refute the hypothesis that some UAP sightings are actually just natural plasmoid activity. It could be a game changer in the field of UAP research.
So plasmoids might help explain some of the mysteries in the sky, but the sources also bring up this concept of quark gluon plasma. Honestly, it sounds a bit intimidating.
I can see why. QGP is a pretty extreme state of matter. We're talking about conditions that existed in the first microseconds after the Big Bang. It's the primordial soup from which everything in the universe emerged.
Okay, hold on. Back up a second. You're saying that by studying QGP, we can understand what the universe was like just moments after its birth.
In a way, yes. When the universe was incredibly young, it was incredibly dense and hot, trillions of degrees Celsius. Under those extreme conditions, matter couldn't exist as we know it. Instead, you had this sea of quarks and gluons, the fundamental building blocks of protons and neutrons.
And that's what QGP is. A sea of quarks and gluons.
Exactly. And by studying it, we can gain insights into the fundamental forces of nature and how matter behaves in extreme environments. It's like peering back in time to the very beginning of everything.
That's amazing. But if QGP existed billions of years ago, how can we study it today? I mean, we can't exactly travel back in time.
Well, we can do the next best thing. We can recreate it. At facilities like the Large Hadron Collider, scientists smash atoms together at incredibly high speeds. These collisions generate temperatures and pressures that mimic the conditions of the early universe.
So they're essentially creating tiny big bangs in the lab.
That's a good way to put it. And by analyzing the debris from these collisions, they can study the properties of QGP and learn how it behaved in the early universe.
It's incredible to think that we can recreate something that happened billions of years ago right here on Earth.
It's pretty mind-blowing, isn't it? And here's where it gets even more interesting. There are actually some intriguing parallels between these primordial QGP droplets and the plasmoids we see today.
Really? What kind of parallels?
Well, both exhibit this kind of order within chaos. They're dynamic, constantly changing, but they also maintain distinct structures and behaviors. It's like there's some underlying principle at play governing how matter organizes itself across vastly different scales.
So what you're saying is that the same forces that shape the early universe might also be at work in the plasmoids we observe in our atmosphere and in space.
That's a very real possibility, and it has some pretty profound implications for how we understand the interconnectedness of the universe.
You know, we've talked about plasmoids potentially explaining some UAP sightings, and now we're delving into the origins of the universe with QGP. It's a lot to wrap your head around.
It is, but all this talk about the strange behavior of plasma, both in plasmoids and in QGP, it begs the question, what if there's more to plasma than we currently understand?
What do you mean?
Well, some scientists have proposed that perhaps, just perhaps, plasma could exhibit some form of intelligence.
Intelligent plasma. That sounds like something out of science fiction.
It might sound far-fetched, I know, but when you consider the complex, self-organizing behavior observed in both plasmoids and QGP, it does make you wonder, could there be forms of intelligence out there that are completely different from what we recognize as life?
I mean, if we can find life in extreme environments on Earth, who's to say what's possible in the universe?
Exactly. Perhaps our current definition of life is too narrow.
So what you're suggesting is that maybe, just maybe, there could be intelligent plasma entities out there, beings of pure energy.
It's definitely a thought-provoking idea, and while there's no concrete evidence to support it at this point, I think it's important to keep an open mind. After all, we're constantly discovering new and amazing things about the universe.
That's true. So as we wrap up this deep dive into plasmoids, UAPs, and the nature of intelligence, what would you say are the biggest takeaways for our listener?
Well, first and foremost, plasmoids are far more than just atmospheric curiosities. They're dynamic, complex structures that could hold the keys to unlocking new understandings of physics, potentially explaining some UAP sightings, and even offering insights into the very origins of the universe.
And who knows, maybe, just maybe, they could even challenge our understanding of what constitutes life and intelligence. Well, that's certainly a lot to think about. Thanks for joining us on this deep dive. It's been an incredible journey exploring these mind-bending concepts.
My pleasure. It's always fascinating to delve into these mysteries with you.
And for our listener, if plasmoids can organize themselves into such intricate structures, could we learn to harness that ability? Could we create new forms of artificial intelligence based on the principles of plasma physics? That's something to ponder. Until next time.
Until next time.